Good evening, everyone. How is that volume-wise? Hopefully it's not quite so scary. A colleague of mine suggested that I was a little bit doom voice. Hopefully that nobody will be being deafened by me. So if the audio levels for my voice and for the background music are not good, please tell me. I'm still getting used to setting these things up, and there are so many mixers involved, it's crazy. In the meantime, let's see if we can find our way to a display. Excellent. Okay, so I have a few things I'd like to do today. One is a little bit of tidying up, a little bit of sort of project improvement. A second is that I'd like to add some way for us to read and sort of decode a representation of a puzzle, because I'd like to get some tests written, and I think one of the most effective ways for us to do that will be to have some representations of Sudoku puzzles that we can load and check that we solve and that the answer that we get is correct. So if I show you what I mean by that, if we take this puzzle here, which is the one that we've been playing with a lot, if I let Sudoku Maker put the solution in, and then I go to share, and I go to Sudoku Pad, and then I click this little edit JSON here, we actually get a JSON representation of the puzzle. And this is a fairly standard representation of the puzzle. It sounds a bit weird, but there you go. It's a fairly standard representation of the puzzle. And what I'm hoping that we'll be able to do is to use this and then sort of deserialize this JSON into a data structure that we can then use to drive the puzzle builder. But we're not going to get there yet. What I want to do first is I want to improve the project. Last time, oopsie, we were looking at running this thing and trying to get a little bit of diagnostics out of it. AI features Copilot. Ugh, I have to get rid of that. Trying to think where that preference will be. I'll worry about that later. Where was I? Yes, we were looking at debugging, and it turned out that debugging is a pig on Nixos. Sorry about that. I did have a look into this. It turns out that the version of the CodeLDB extension that's available in Nixos, that therefore works with Nixos, is older than the most up-to-date one, and so I'm going to need to look at packaging up the newer version before I can get any further. So I'm not going to worry about that. Let's just let the extension host reload, and we're ready to go. So the first thing I'd like to do is this project is lacking a README, and for any of you that are used to these sorts of things, when you visit a project on GitHub, normally you see a README here. At the moment we're seeing the MIT license. Obviously that's suboptimal, so let's start by giving our project just a little bit of a description, and you know, just so that people who land on this can get somewhere. I think that's a good idea. So I'm going to create a README at the same level as license, and let's begin. So a logical puzzle solver for orthogonal grid cell-based puzzles such as Sudoku. She aims to always make logical deductions rather than brute forcing solutions. Kaji is maintained as part of a live coding exercise, which can be found at... Now let me find my playlist link, because I think that's probably the best thing for me to pop in here. messy. View playlist. And can I copy a link? Is there a share link here? There's a share link. Copy. Yeah, so it turns out that's a horrible link, but fair enough, which can be found at YouTube. Right, there we go. I don't really propose saying much more than that for now. I think that's good enough. We'll worry about adding more to this later. What I really want to do is I want to look at the documentation and improve the documentation a little bit, particularly the documentation in the Kaji crate itself, because as we come to use these functions more and more in our solvers, we're going to want to get the documentation and understand what's going on. So let's begin by we don't need anything more than that, and get that pushing. So if we do a cargo doc -p Kaji -open, then this is the documentation that we get for Kaji at the moment. And what I really would like to do is I'd like to make it so that we get, at least for all of these structs and enums and the traits, enough documentation that a user stands a chance of developing some new capability. And the way that I'm thinking, that I'm going to do that, number one, we should probably fix whatever's going on here. So that's in symbols.rs line 11. So per symbol set, yeah, it's not symbol set, is it? Cells can only have one symbol present in them per symbol set. And it's saying that symbol set index is not available in the module Kaji. So where does symbol set come from? It's actually symbol set ID, not symbol set index, and lo and behold, everything is happier again. And if we run cargo doc-p Kaji, we no longer have any errors. So our goal is to make it so that everything that's exposed in Kaji has at least a trivial one-line piece of documentation. So what I'm going to do is I'm going to come up to the top level. Now, we can do a bit better in that main documentation later. But what we're going to do is we are going to say deny missing docs. And that's going to immediately cause pretty much everything in Kaji to error out because we're missing documentation for pretty much everything. And if I run cargo doc at this point, it's going to error because everything's missing. Let's start with this because this only says one thing is missing because we've got the documentation for logical step. And in fact, that realistically ought to be a link, but we don't have any documentation for technique itself. So a solving technique. Each solving technique is a logical step along the way from an unsolved puzzle to a solved puzzle. Techniques may be as simple as this cell can only be X, so it's X, or as complex as chaining inferences through multiple steps. There we go, we fixed that one. Constraint is probably similarly, yeah, so we need to a puzzle constraint. Constraints limit the possibilities of cell values within the board. Constraints are defined at puzzle build time and apply their limitations at the start of solving and whenever the board changes in areas they are interested in. Now, at the moment, obviously, that latter half isn't implemented, but we will get there eventually. Now, the result of running a logical step in our solver. See, constraint doesn't talk about that, but the applying limitations will. So let's go here. And this was during this step in the solve, something happened. Nice and simple. And now give ourselves a few examples for logical step. So create a new logical step based on the given description. And we could write a little example here. So if we did that, then in Rust, when you have an example in your code documentation, then that actually forms a test. So we're going to have to use logical step, and the hash at the beginning tells rustdoc to not show us what's that line. And here we can go, you know, let step equal logical step action hello. And remember that logical step doesn't implement EQ or anything, but what we can do is we can assert matches step logical step acted hello. No, because that's a string, so we just stick an underscore in there. So we've demonstrated that that's what's going on. What I'm going to do now, very briefly, is turn off that deny missing docs, and I'm going to go cargo test -p kaji. And you can see that in the doc tests section, it's actually gone and run that as a documentation test. And if I run cargo doc -p kaji, and I come along to our documentation here and we come to logical step, then under action, you can see that code minus that use line, which had a hash at the start of it, as an example of how to use that function. Probably not going to do many of these for now, but longer term, as we get further and further into this, we will probably be writing more of these tests where appropriate. For now, I'm just going to carry on doing this development change. So we're going to go back to back to constraints.rs and continue going. So push cells. Push a description of a set of cells into a logical step. This takes an iterator over cell info over, yeah, I think I can do borrow. Can I do borrow cell info? No. It'll do over cell info, or actually what I can do is say borrow cell info like that, just because the borrow is relevant here. Takes an iterator over that and renders the cells as their RXCY representation into the logical steps description. The step must be a logical step acted, otherwise this will panic. In fact, we can say panics, the step must be a logical step acted, otherwise this will assert. No, it will panic. So we're now saying what's going on there. we can give an example. For example, if the iterator yielded cells R2C3 and R3C4, then the string R2C3, comma space R3C4 would be appended. And we've got push str. So what I'm going to do is I'm going to take all of this, bring it down to push str, simplify it, copy it again so it doesn't take that. We don't have that example, and it's just push a string into a logical step, and then I'm going to copy and paste that down there because we'll need to describe that in a moment. This simply appends the given string argument to the step description. And then down here, this one is push a set of symbols into a logical step. Iterator which yields and renders the symbols as their display names. For example, this may append the string 5, 4, 2. Right, so constraint is now documented. Let's move on. Rules only has 2, and of course it's because trait rule is pretty trivial. So let's document this. Remember also that the module doesn't have any documentation, but we'll worry about that in a minute. A rule for a puzzle. Rules are used to construct puzzle. Can I not do that? Is that not fair? Puzzle is definitely exported. Sorry, puzzle builder is definitely exported. Puzzle is definitely exported. It's got to be. Why is that not? Oh. Well, that is code documentation. We'll see whether it renders in a moment. Tick, tick, tick. Apply a rule to the given puzzle builder. This takes the requisite information about the puzzle and applies symbol sets, constraints, and techniques to the puzzle builder so that the resulting puzzle can be solved. Now, let's just go back to the docs for a sec. Are you telling me, no, yeah, puzzle is definitely exported, which makes sense. Although, does it need to be? Yeah, it does. It needs to be exported because that's where the solve function is. So, apply a given rule. We're good there. Let's keep moving. Symbols only has 6 things that haven't got documents at the moment. So symbol set build. Ooh, goodness. Click on the wrong things all the time. Right. So symbol set builders. Build a symbol set. In order to construct a symbol set for a puzzle builder, this utility builder should be used. Once this is built, which is a case of symbol set builder : build, leave. The puzzle will contain the set of symbols appended or inserted here. Right, I'm just very briefly going to turn that off and find out what's going on here. No item named Kaji in scope. The struct symbol set builder has no field or associated name build. Let's check both of those things. Symbol set builder is called finish, so that's true. So let's fix that one. That's more like it. And the other one was in rules. It's not Kaji puzzle, it's going to be crate puzzle. There we go. Okay, let's keep going. So new symbol. Create a new symbol with the given name. Later, we're going to have to start adding things like values into symbols, because for variant Sudokus, sometimes the digits value matters. But for now, it just has names. So here, we are pushing into a symbol set builder. So this is going to be add the given symbol to this set. And then finish is going to be add this symbol set in its entirety to the puzzle builder. And now down here we have symbol index, which is pub on symbol, but in practice should be pub crate, so we can fix that immediately. And set index should be pub crate, and that solves everything for symbol. Ooh, there's going to be loads in puzzle. Oh my goodness me, look at all that red. Here we go. I'm hoping that a lot of these things can be unredded by unpubbing them, but we'll find out. So puzzle is definitely exposed, and for the moment at least, it should remain exposed. So a representation of a puzzle which can be solved, or which may be solved. Puzzle builder is a way to construct puzzles piece by piece. Cell info. Actually going to do it before there. So information about a cell in a puzzle. Cells are in an orthogonal grid, but are not necessarily tightly packed. Each cell has a row and column number associated, and that is a unique coordinate for the cell. Regions. A region is a set of cells with some kind of uniqueness constraint. A region is a set of cells where one or more of the symbol set symbol sets must be unique within the region for the puzzle to be considered solved. And now we have cell index, a an index into the cells in a puzzle. We have a region ID, which is an index into the regions in a puzzle. This is realistically a cell info reference symbol set ID, an index into the symbol sets. Do we actually ever get to see a symbol set? So puzzle, let's just confirm for ourselves. Puzzle lets us get an iterator of the symbols for a symbol set, but doesn't let us, and it lets us get a symbol set by name, which is an iterator of symbols. But for a puzzle, we can never actually get anything better than that. And in practice, you're very rarely interacting with puzzle. You're almost always interacting with a solve state that has symbols by name and so on. And that has symbol sets, which give you symbol set IDs, but there's no actual give me information about a symbol set. So for now, we're not going to do anything about that. We're just going to say an index into the symbol sets in a puzzle. Solve state is a representation of an in progress solve. I'm going to say in practice, this encapsulates a puzzle and an in progress board. Symbol choice. So this is a representation of which symbols are available. Representation of which symbols are available. And these are symbols are available within a board. Each cell can have has a symbol choice for each symbol set. There we go. Effect. Nothing changed on the board. Changed. Something changed on the board. And at this point, I imagine, half an hour in, you guys are slightly bored with me just adding trivial documentation. So I'm going to jump back here. I'm going to comment that out, and I'm going to comment that and say to do some more docs until this can be left in. And we're going to call that stage of this evening good. Right. With that pushed, let's move on to thinking about writing some kind of puzzle loader. Now, Kaji rules has stopped working. Why has Kaji rules stopped working? Techniques, single. Did I? Aha. See, this symbol index, it turns out, is actually needed. Bummer. That'll teach me for not checking more before getting there. So, where I made these no use. What I'm going to do is I'm going to unpub it. I'm going to give it some documentation because we should have before. Retrieve a raw usize which represents the index of this symbol in its symbol set, in its set. Note, this is not guaranteed stable between runs and should only be used to index an array of symbols or similar in a technique. Or other constraint. So that's made it clear that actually this is not meant to be used except as a raw thing, and it's possible that in future what we might do in our symbol set builder is when you say finish, we might randomize the order of the symbols so that we can, from test to test, guarantee that we're not actually relying on the symbol order. But I won't worry about that for now. So let's just go. Turns out symbol index is needed. And guess what? My commit messages aren't great, but I'm fine with that for now. So we're going to talk about a loader. And one option is that we put that loader into Kaji rules, because it's going to have to potentially talk about rules. Another option is that we create like a Kaji utils crate. And the third option is that that loader realistically only belongs to our Kaji program. And the question basically comes, are we going to be using this as a library where we need to load from JSON? And roughly my answer is maybe. So let's write Kaji loader. So cargo new -- lib Kaji loader. And then let's get going. So Kaji loader. Cargo add Kaji and Kaji rules. And that's not going to let that happen. So let's just type them in. Kaji path equals Kaji. Kaji rules. Path equals Kaji rules. Right. And our Kaji loader is going to be, add the ability, mechanisms to load puzzles into Kaji. Right. If we're going to support the JSON that we have in this, let's grab some JSON. So use currently filled in values as the solution. Copy. I'm going to make a tests directory because we're actually going to write some unit tests in here a little bit. Or we are going to write tests, but we're actually going to have some sample puzzles. Give me one moment. Sorry about that. Didn't want to sneeze at you all. And now in here, in sample puzzles, let's say we are going to create puzzle1.json, and I'm going to paste that JSON in. Nice and simple. Did I get the close brace all the way at the end? Yes. Okay. Nothing to be done there, except I'll probably format it. hopefully that will format it a little bit. What have I... Oh, flipping heck. Give me one sec. The problem with that is a pain. Parse error near close brace. What happened? Tree is dirty, yes. Parse error near close brace. I don't know what's going on there. Never mind. We won't worry about that for now. I'll worry about formatting it later. The goal is to be able to load that JSON. So we're going to end up with a struct that represents this to some extent. And then we're going to transform that struct into a puzzle that can be solved. One of the nice things, which happened because we had ticked this use currently filled in values as the solution, is that we have this solution here, which we can actually use to verify that our puzzle is correct. We'll worry about cages later. That's where killer cages turn up. The cells are the grid in question. So obviously, those are all of the given digits in the grid. Regions are interesting. These are actually the 3x3 regions. So if we come here, this set of cells is a region and actually comes from this constraint here. So you can see region 1, region 2, region 3, and so on. So we're actually going to need to have our Sudoku rule be able to use these rather than constructing the regions using that weird mathematics that we did before. I'm all for that. I think that's a good plan. Let's come down past the regions. And that's everything. So, useful things to note here. If size is not specified, then it's a 9x9. If size is specified, it might not be a 9x9. We can also compute the size of the grid by saying, well, how long is the cells array? Because that's all the rows. And for each row, how long is the array? Because that's the columns, and that should be square for a Sudoku puzzle. So just check. That's 3 blank 6 blank 8 2, 3 blanks 3 blank 6 blank 8 2, 3 blanks. Yeah, so it's row by row. We want to load this into our thing. For each cell, we're only caring about the value field. I suppose in theory there might be more in there. And we're going to have to be pretty lenient in loading if we're going to stand any chance of eventually managing to decode all this stuff. So let's start to write a struct or structs that represent all of this stuff. So I'm going to call this raw. And I'm going to make it public because why not? And let's have, pub struct raw puzzle data. And we're going to go from here. Let's get the JSON back up because it will be useful for us. I said we don't really care about the ID, but we may as well store it. And we're going to care about some of the metadata. So I'm going to say that's raw puzzle metadata. And we'll implement that in a moment. We don't care about cages for now, but we do care about cells. And this is going to be a vector of raw puzzle cells. And we care about regions, which is a vector of I mean, realistically, that's a tuple of row and column numbers, right? So this is going, so that then we can have regions, which is a vector of raw row col pair. And do we need anything else out of this puzzle? No. To make sure that the JSON fully parses, though, we're going to... Are we going to do any more than that? No, we'll leave that there, and we'll worry about exactly how we're going to parse that in a moment, because we're going to talk about Serde. So let's write pub struct raw puzzle metadata. What do we care about here? We don't really care about the source. We do care about the title, and we do care about the solution. And we're going to have raw puzzle cell. And the only thing we care about here is the value. And what can values be? Well, they're always numbers. So we'll go with usize. Actually, no. What we'll do there is we'll go with I32 and the option usize. We'll go with option usize because that way, if it's not present, we don't have a value. If it's present, then we do, and we're going to do a given digit. Let's come down and look at regions. That requires us to have pub struct raw row col pair. And as I said, this is a tuple realistically of row and column. So let's just do usize. And now, in theory, that's everything that we need in order to read this JSON in and do something potentially useful with it. So how are we going to read it in? Well, there are two main libraries for reading in JSON. I say main because there's obviously a whole selection of others, but the two that I'm thinking of are Serde and Facet. I've never needed Facet, so for now I'm going to stick with Serde because I know Serde, but later if we decide that Facet would be better, we'll just switch. You know, the functionality that we need will work with either of those, so let's just go with the one that I know for now. For those of you who've never used Serde before, it's an incredibly powerful library. Serde.rs is its documentation. It's a framework for serializing and deserializing. There's all sorts of information here. There's loads and loads and loads of data formats. I actually maintain a YAML representation that can be deserialized with Serde. So there's lots of opportunity there. So we're going to use Serde. I'm going to cargo add to Kaji. What do I call it? Kaji loader. Serde with the derive functionality. And I'm going to add a library called Serde JSON. And that gives us our JSON reading capability as well. So what we really want to do is we want to gain access to all of this stuff. In practice, this is just raw data. I don't particularly care about writing accessors for all of this stuff. So let's just make all of that pub for now, which will shut up all of that complaint. And let's try and write impl raw puzzle cell, sorry, raw puzzle data. And I want to write pub fn parse, or should we do from str? We'll call it load actually. And that's going to take some s, which implements as ref str and gives back a result. And we're going to be using Serde JSON, so we'll use their result self. So we're going to get our string however we got it, because that might be like literally a capital S string. It might be all sorts of things. And then we're going to try and load it, and we do that by, for now, just saying Serde JSON from str s. And it's going to say that we do not implement deserialize. And the way that we're going to do that for now is we're going to add a derive. I'm going to stick debug just because we'll use that to output where we are. And we're going to deserialize. that's going to then complain that raw puzzle meta doesn't implement it, raw puzzle cell doesn't implement it, and raw row col pair doesn't implement it. So this might be enough. It probably isn't, but it might be. And we're going to add some tests where we actually try to look at our puzzles. So let's mkdir Kaji loader tests. And let's begin writing a test. We'll call it simple.rs because these are hopefully going to be some fairly simple tests. In fact, we specifically are going to be mucking about with the raw data representation. We might later have non-raw data representation. I'm being overly cautious here. And we're going to write a test, which is going to be load puzzle1. And we're going to say puzzle1 is std.fs read to string of, and we need a path. So actually, let's say it's load sample puzzle1.json, and let's write that function. And that's going to return a raw puzzle data. And we're going to need a path. And when you're in test code, certain environment variables are available to you. So one of the environment variables that's available to us is one that tells us where cargo.toml is for the crate that we're currently building. So we're going to say that ctoml is at I think it's just env-pling of cargo manifest dir, and we'll just double check that. So if we come to is it the front page of docs.rs? No, docs.rustlang.org, the cargo book, and we search for environment variables. So these environment variables change what cargo reads. It also sets all of this stuff. Things it sets when you're building a crate look like this. Things it sets for build scripts look like this. So these apply to cargo test as well. So cargo manifest dir is the directory containing the manifest of the package. And it does say we can use env-pling to get it. So we get the cargo manifest directory, and realistically we want a path buff from that. So let's load a path buff from that, and then we are going to say fpath is ctoml .join format of /sample puzzles/leaf. I mean, there's all sorts of wrong here. I really shouldn't be using format there. I shouldn't be using strings, but it's probably good enough. And now we're going to go. Actually, rather than returning raw sample data, we're going to return a string object, because I want to do the parse in the test in case we're expecting to fail to load for whatever reason. So this is going to now be std fs read to string of fpath expect unable to read file. So we've got ourselves our puzzle, and then we're going to go data equals raw puzzle data load puzzle1 and unwrap, because we expect to be able to load it. And now we're going to do a few simple asserts here. So one is that we're going to assert that there is a solution. So we're going to say, well, actually, let's check that we can get even that far. cargo test-p kaji loader. So it does load. That's a good start. What would happen if we didn't have a solution? So I'm just going to stick a space in there so that we don't have a solution. Now we fail to load. That's not good. So if we come back here, we need to be able to cope with certain things being missing. I think the ID will always be present. I think the metadata will always be present. The cells will always be present. The regions will always be present. Within the metadata, though, there may not be a title, there may not be a solution. So we're going to say Surday default, or we can stick an option on that. Let's stick an option. Because that way, if they're not present, they're not present. We already have an option on value, and we already expect all of that stuff to be there. So that should be enough to always load. So let's just enable that to come back, and we'll carry on. For now, we're able to load that puzzle. So the next question is, what do we want to do in terms of turning that puzzle into a something that can be solved. So we now have a raw puzzle, and what we really want to be able to do is we want to be able to convert that raw puzzle into rules. So let's write something that's able to do that. Now I'm just thinking, do we think that loading the puzzle in is independent of being able to convert it to rules, and so Kaji rules should know how to read from raw puzzle data? Or do we think that raw puzzle data should be able to drive Kaji rules to generate stuff? If you have an opinion on that, feel free to put it in chat. I am going to take a couple of minutes just to get myself another drink, and then I will have a look and see if anyone has expressed an opinion. Okay, let's have a look. No one's said anything, so I'm going to assume that you're all good with whatever I pick. And my vote for today is that we're actually going to make it that the loader is lower level than Kaji rules, so Kaji rules will be able to deal with the loader's data types. So I'm going to take Kaji rules out of the dependencies for the loader. Nice and simple. Here, for now, I'm just going to stick an underscore there to shut it up, because we'll worry about doing some more stuff with that later. This is going to be good enough. So let's come along to Kaji rules. And let's add Kaji loader to this. My theory here being that what we probably want to do is to teach the rules, specifically the Sudoku rules, and possibly the regions rules, although the regions... So non-repeat region, the region has already been constructed, so we don't need to worry about that. So it's the Sudoku rules. So rather than having this complicated load stuff, we are going to expect to take a solver. Blah. We're going to expect to take a raw puzzle and initialize with that. So at the moment we initialize with a size. We're going to stop initializing with a size, and we're going to start initializing with some raw puzzle data. Won't that be fun? Raw puzzle data. And I tell you what, for now, I'm just going to stick size, usize back in, and size will be raw.cells.len. This is so silly, but you know, this is the way we are. That lets us at least continue with the work that we're doing. And now Kaji bin, instead of having all of this crap, you know, and adding the constraints and so on, we are going to take away all of this. We're going to have to work out how to do our given digits eventually, but now we're going to say puzzle is raw. We're going to have Kaji loader as a dependency here. So that we can say, oh, we need, is it time to add a command line? No, for now we're just going to load sample puzzle 1 and we'll go from there. So let's actually come and steal load sample from here because we are simple people. And that's going to complain that pathbuff isn't available, which we can just import. And now we're going to go let raw equal load sample puzzle1.json. And we're just literally going to go raw puzzle data load that. And we're going to say, oh, what's raw puzzle data? Import that. We're getting somewhere. So we're going to go Sudoku grid : new. And I tell you what, we're actually going to make Sudoku grid borrow the raw puzzle data because it's not fair otherwise. We'd have to keep cloning it for any of the other constraints that we want to teach it. So where's our rule? Here's our rule. It's going to take a borrow raw puzzle data so that here we can say new borrow raw dot apply borrow mute builder. And we're going to have to do the same for the given digits. So let's find that constraint, given digit. And again, for now, I'm not going to write the implementation here. I'm just going to go let givens equals vec boom so that I can say raw is a raw puzzle data, which isn't used, but that's fair enough. Missing a semicolon there just to shut it up until I can get back to here. So I can then say given digits new borrow raw this is a constraint, so we need to add that constraint to the puzzle. So builder dot add constraint for that. And that's given us all the information that we need. Sudoku grid is going to end up with a borrow. Given digits is going to end up having to copy the data immediately upon construction, because otherwise we're a bit screwed for adding the constraint, because the constraint requires that the constraint is tick static. So let's do the given digit one first. We're going to say let mute givens equals, and then we're going to go for row. But we're going to go raw row and row in raw dot cells. Dot iter dot enumerate. So it's giving us a user, an index, and the row, and then we're going to go for raw column cell in row dot iter dot enumerate. If let some value equals cell dot value, givens dot push raw row plus 1 raw column plus 1 value. That loads our given digits, and we don't have to change anything else to make that happen. The Sudoku grid at the moment, we've just said it's a 9 by 9, we don't care. This is a 9 by 9. So in theory, cargo run can do what it needs to. Now, remember that the thing that we're loading at the moment is expecting to have a finned X-wing, which is not a technique that we're going to aim to solve at the moment. But it's working, which is great. I want to make the Sudoku grid load better, and I want to make, for now, sample 1 or puzzle 1 be the solution that we know we can actually solve. So what I'm going to do is, remember, it's row 2, column 5 is 9. If we set that one, then we don't need the finned X-wing. So I'm just going to go into sample puzzles. I'm going to copy that as puzzle 2. And now puzzle 1, not row 1, but row 2. 1, 2, 3, 4, 5. We're going to stick that value in, which means that if we cargo run, it solves. And so we actually have a puzzle. We know it solves. So what I'd like to do next is I'd like to check the solution. Because if we can check the solution as well as everything else that we've done, then I think we're on to a winner. So we print the board, and we can go if board dot solved, and we're going to start adding some things to that, or, well, solved, we can unprivate. So let's go and do that. Fn solved. Are we an impl board? We are. That's allowed to be public because that just tells us, is the puzzle solved? So if the board is solved, let solution equal board.solution. That's a function that doesn't exist, but we're going to compare that to the raw puzzle data's metadata's solution. If let some real solution equals raw dot metadata dot solution. Borrow that. Println solutions if real solution equals solutions match, else println solutions do not match. So we need to implement this method. So this is going to return a string. We're going to assert self.solved, because if we're not solved, there's no point trying to generate the string. Otherwise, the solution string for a puzzle is going to be just to iterate across all of the cells in order, all of the choices in order, and generate a string. So let's mute ret equals string new. Ret is going to come out. And what we basically care about here is we're iterating across n cells. And if we remember the board definition here, we also have n symbols, which tells us how many symbols we have. So we're going to go for cell in. Well, in fact, we can just do for choice in self dot cells, because that's a raw symbol choice list. Oh no, puzzle knows what the symbol sets are. Sugar. Solution's going to have to go on puzzle. It's really annoying, but this is life. Where's our print board? It's here. So let's stick our solution here. So it takes a self and it takes a board. And we want to assert board solved. And we're going to think about how to do this. And the way that we're going to do this again is we're going to go through rows and columns, because I think that's actually probably more sensible. So we're going to do that. We don't need to care about the row width, because we're just accumulating everything together into one answer. Let's move that assert up there and bring that down. And then we're going to iterate row and column. And we're going to say, get that, get the choices, get the single value, get that. Ugh. I'm just going to copy all the way to there, and then we'll worry about it a little bit more, because that's going to be a close and a close and a close and a close and a close. But we're not going to print symbol. We're going to ret.push str. Well, ret.push. Format that. I mean, that's hideous, but it gets us there in theory. And now it's not board.solution, it's puzzle.solution, borrow board. Stick a borrow there to shut up the comparison. Solutions match. Hurrah! Right. We're getting there. The last stage is to actually write the loader for the Sudoku grid. And what we care about here is the regions, because we cannot handle our regions weirdly. It's not allowed. Yeah, so our raw indices are actually going to be good, because they're going to index into rows and columns nicely. So we just want to duplicate the raw offsets into our regions. So we're going to go regions is a vector of vectors of raw puzzle cells. No, raw puzzle, raw row column pairs. There we go. And we're going to say size, and we're going to say regions come from raw.regions.clone. And that's going to complain that clone exists for the structure, but it doesn't exist for the whole type. So now we get to come back to here, and we get to derive clone for And in fact, we can derive copy because realistically it's copyable. Regions is never read. That's fine. We can come down here and we can get rid of all of this complexity because we don't need this complexity. What we can do instead, because those are the boxes, and we do boxes.push builder.add region. Yeah, okay. So for our boxes, we need to go, for region, or for raw region in self.regions dot iter.enumerate. So it's R, no, and raw region. And now we're going to construct the region. And the regions are constructed, remember, with a name and something that impulls into iterator. So box name is box that, which is no plus 1. Box cells is raw region dot iter dot copied dot map given a raw row column pair, raw row, raw column. Nothing. And then we're going to go boxes.push builder add region new box name box cells. That's going to whine that box cells has the wrong type, but that's fine because we can now get to here and we can say that it is rows. Oh no, because we've overwritten rows here. So these are going to be region rows, just so that we still have access to rows at this point. So it's going to be rows, square bracket, raw row, square bracket, raw column. And that is a what? There's a borrow going on here. Rows is a vector of cell indexes. But we're borrowing that. Yes, that's an item. That's fine. Why is it complaining that things don't last long enough? Let me see the whole error. So, move occurs because rows has type that, which does not implement copy, and into iter is called. Of course it is. So we're just going to call iter copied enumerate. The trait bound vector of things is not there, so never mind, just enumerate it. Is that better? Region new, expected cell index found borrow cell index. Row dot iter dot copied. There we go. Right. So that's pushed things around so that in theory we're adding the right regions. If we cargo run, solutions match. So we're now loading the regions from the puzzle data as well, which I think is really important for our solution here. Because if we, for example, had an irregular Sudoku, we would want to be able to load our regions properly and have it work. Do I have an irregular Sudoku to hand? If I went to Sudoku Maker, do I have an irregular? Regions. Don't think I do offhand, so we're not going to test one of those for today. Let's just add all of this stuff up, and then I think we're probably in a reasonably good position to stop for today. One thing that I do want to do next time is to start to look at X-Wings. So in a moment, I'll show you what I mean by how I'm going to start to do that. So what we're going to do now is we're going to add Kaji loader and sample puzzles. And we are going to commit, add initial loader and puzzles. We're gonna top level cargo.toml at that. Yeah. Just going to put that in there as well. And now we're going to do a git add dot. We're going to git add Kaji source puzzle add solution string generator. And everything else is to do with consuming from raw puzzles. Kaji star add support for loading from raw puzzle data. Right, all that functionality is pushed. So if any of you would like to play with that, you can. Next time, we are going to try to add a new technique. The technique that we're going to look at is non-finned X-Wing, because that's like our first step. Finned X-Wing is an extension of that. Now, there's all sorts of ways that we could kind of describe these things. We could try to do them generically as X-Wings, swordfishes, jellyfishes, blah, blah, blah. Fundamentally, what an X-Wing is a relationship between rows and columns. So if I just run this logical solver through to a solution, you can see that there's hidden singles, there's naked singles, there's hidden singles, there's one naked pair, which we know we implement. There's naked singles for everything else, and there is this one X-Wing step. So what we're going to do is we're going to clear out, and we're going to have a look at that X-Wing step. Hidden, 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 naked, X-Wing. So this is the point that we're caring about. So it's on 9s, and it's in rows 5 and 1. So if we look at row 5, and we look at row 1, and we look at where the 9s can be in those rows, we see the 9s there in row 5, and we see the 9s there in row 1. This rectangle is effectively saying that in those two rows, the 9s are always in the same columns. And what this means is that in this column and this column, the 9s must exist in row 1 and row 5, and therefore the 9 cannot exist in either of those two cells. And that's that elimination. And that's what then lets the rest of the puzzle solve as naked singles. I don't know. It's possible that the solver settings can have X-Wings turned off. So if we turn that off and we clear and we run, then what did it do instead? Oh, it still did an X-Wing. Cursed things. Let's turn off swordfishes. Let's turn off those. Let's turn off those. Let's clear and run. It's just not obeying us, is it? Or right, oh no, it's then gone to contradictions. So let's turn by contradiction off. Clear and run, and it gets stuck. So this is the point. This is the point where our solver would get stuck, because hidden singles, and naked pairs we definitely do. But this is the point where it goes, I cannot get any further. And the next step that it would do is it would notice that in rows 1 and rows 5, the 9s are in columns 5 and 8, and therefore it can knock 9 out of those 2 cells. So that's the thing that we're going to have a go at implementing next time. It's not going to be now. In the meantime, if any of you have any ideas for things that you'd like to see, please do reach out to me, because I'm very happy to take direction on what people would like to see as the next steps. Otherwise, it's going to be X-Wings, because they're interesting and I think they're going to be useful in a lot of puzzles. So thank you very much for watching, and I will see you next time.